Hi, I'm your observationist here, and I want to talk to you today about global anoxic events. They're very important to the process of climate change, as you'll see. Let's talk about first what are they and how are they formed. Well, if we look at the world today, we have what's called a thermohaline circulation. That is the ocean circulation that's global, covers the entire Earth, and it takes the ocean water at the surface, which is in red here, and brings it down into the depths. And when it goes down to the depths, it brings salt and it brings oxygen down to the depths. That's how fish are able to breathe 5,000, 10,000, 15,000 feet deep. You go down to the bottom of the Marianas Trench, also called Challenger Deep, and you go down there 30,000 feet deep. There's oxygen down there. There's fish down there. So how does it get there? It gets there through this. Now, there are times in the past, in the geologic past, during the Mesozoic, when this shut down and the ocean became anoxic, without oxygen. Hence the words global anoxic event. And when that happened, that had impact on the development of oil, of our oil reserves. Now, when I was a child, maybe a little bit older, they discovered oil in the Arctic, in the Arctic Ocean north of Alaska. And even then, I was wondering, how did they know to even look there? What would make them think there's oil there? And if you go into go a little bit later, and you talk, let's say 1990s, year 2000, they were talking about oil being in the South China Sea. And I was go, wait a minute, they didn't even do any exploratory wells. How could they even know there's oil there, let alone estimating how much? Which is what they wells do. They'd estimate how much oil. They're like, how are they doing this? What would make them think there's oil there? Well, here's how. When this shut down, and there's and the sea is anoxic. Now the sea was anoxic about 20 or 30 feet below the surface, because wave action would keep the water at the top oxygenated. So that's how the fish of today were able to survive through those events. So when an animal died, it would float down below the oxygenated area down to the bottom of the ocean, and specifically on the continental shelves, and would drop there, and then it would rot in an anoxic way, not normal oxygenated rotting. And over time, that's how the oil deposits were created. And that's why, if you look at where we get the majority of our oil nowadays, it's from these areas. That's why off the Texas coast, there's a lot of oil. Arkansas, not so much. And Nebraska, not so much. But down on the Texas coast, yeah, oil. You're talking about Persian Gulf, Kuwait, that area, a lot of oil. Why? That area was underwater during the Mesozoic, as was Texas. And this is why we're getting oil in these continental shelves. We have oil in the North Sea. We don't have oil in the Alps. So we have oil, where, in the coastal areas. That's where we mostly have our oil now. Now, another way of looking at it is that Mother Nature, in her infinite wisdom, was sequestering excess carbon down and deep into the sea so that we couldn't get at it, which we outfoxed her. We got at it. So now we're putting all that oil back into the air. Now, let's take a look what that meant millions of years ago. Now here's the timeline of the Earth, starting zero on the right, going all the way back to the Cambrian, 500 million years ago. This is the Mesozoic, as I was talking about, where most of the global anoxic event occurs. There was one that did occur later, and that was at what's called the Paleo-Eocene thermal maximum. And anyway, so if you see this era in the Mesozoic, you notice that was when carbon dioxide was also very high compared to what it is now. This is where it is now, now it's around 400. Back then, we were talking 1,000, 2,000 parts per million, a lot higher than today. So we had multiple global anoxic events, which are not shown here. Now, when those events occurred, like I said, there'd be no oxygen below, and the anoxic decay would create hydrogen sulfide gas. So one of the ideas is that the Earth smelled like rotten eggs during those time periods because of that. And when that happened with the during very, very warm periods. How warm? Typically, we're talking where it would be subtropical weather or climate in the polar regions. That's how warm. The last one that occurred about 55 million years ago during what is called the Paleo-Eocene thermal maximum. That's noted by this little blip of temperature here. By the way, the blue is the estimated average global temperature. And during this time, there were crocodiles in Alaska. There were snakes in Alaska. I mean, like boa constrictor type snakes. And this was very different than what you see today. But that happened because during that time it was very, very warm. Now, what causes that? What causes that event to happen? Well, let's go back to this. What causes the circulation? Well, what causes the circulation is basically temperature. And by that I mean the temperature differential between the tropics and the polar regions. So if you look at the Earth and its climate and its really basic climate zones, you have the tropics, the temperate zones, and then the polar regions. This is where it's hot, this is where it's warm, this is where it's cold. Okay? What drives this entire system is the differential of temperature between the pole and the tropics. Now, what do we know? What have we been seeing since the start of global warming a couple hundred years ago? We're seeing the temperatures of the polar regions rise faster than the temperatures in the tropics. Tropics have barely budged, but here and here, the temperature's gone up significantly, and hence that's why we're getting the melting of the permafrost up there and melting of glaciers, etc., etc. But that temperature differential is what drives that circulation. Well, as these temperatures converge, as the polar regions warm up vis-a-vis the tropical region, then what happens is that those climate systems driven by that temperature differential, one of them being the thermohaline circulation, begin to slow down. We're already seeing the Gulf Stream slowing down. And as the Earth gets warmer, it's going to slow down more and more. Now, therefore, what is the potential result in that if that keeps going? And to me, it's obvious that the worst potential would be another global anoxic event. So that's the seriousness of it. What can we do to prevent it? We need to somehow get control over CO2 levels in the atmosphere. We need to be able to control that. We need to be able to not just stop adding to it. We need to somehow start bringing it down. Just maintaining it where it is not adequate. Anyway, with that, on that cheery note, I hope this sparked your interest. If you have any questions, please do leave them. And if you like this, please do like and subscribe. I'd appreciate that. But if you have any questions about this, or you want me to go deeper into it in one facet or another, please just let me know. And if you disagree with me on any of this, also let me know. Just please be respectful. Thank you. And with that, I'll say good night.